This is the video for density. We're first going to start off with the definition of density and some properties about it, and then we're going to go into the math part. So, first, before we can really get into what density is, we need to talk about what the difference between mass and weight is. So mass is a measure of the amount of matter that an object contains. Weight is a force that measures the pull of gravity on a given mass. So the key things in these definitions, and I would suggest you highlight them as well, is mass is a measure of the amount of matter. Okay, so the mass is the amount of matter that an object contains. Weight is the force that measures the pull of gravity. So it's the force of the measure of the pull of gravity. So if you were to compare these two things, which one can change and which one does not change based on location? So if you think about it, mass, no matter where you are, whether you're here on Earth or the moon, should stay the same because your amount of matter does not change. Weight depends on location, meaning whether you're here on Earth or the moon, you're going to have a different weight because there's a different pull of gravity. Okay, so you need to know that there are two different things. Scientists and people use them as if they're the same thing, but they're not. Okay, so density. You've been learning this concept since elementary school. This is one of your first science fair experiment projects that you do in elementary school. You're watching things float and things like that, watching them sink. So less dense objects are lighter, therefore they float. More dense objects are heavier, therefore they sink. So ice compared to the actual water is less dense, so it actually floats. Things that fall to the bottom, rocks and so forth, are more dense. Okay, so if you have a graph that looks like this, because we're going to look at graphs all throughout the semester, you've got to know what's going on. So the x-axis is volume, mass is your y-axis. If you plot that relationship of an object and look at its slope, slope meaning rise over run, so you get the change of y over the change in x. The change in y is your change in mass, your change in x is the change in volume. So if you actually put that into an equation, you get m over v, which tells you your density. So you're able to calculate the density of an object simply by looking at the slope of a line, because the density of an object never changes. Okay, so as the mass changes, the volume is going to change and vice versa. Now, a couple things that we are going to be looking at as well is, okay, if mass is constant, and you're looking at different objects here, let's say you have two objects with the same mass. Density and volume are inversely related. This means that they are opposite. So if you have 1 pound of brick versus 1 pound of feathers, okay, the mass is the same, they're both 1 pound. Density, which one is less dense? The feathers. Okay, right, feathers are lighter than your brick. So since the density of the feathers is less, that means its volume has to be more because they're inversely related. Now with the volume, okay, so we're going to take the volume in consideration this time. So if we have a liter of feathers and a liter of brick, density and mass are directly related. So the less dense objects are going to have less mass. Okay, so same volume of brick versus the same volume of feathers, which one's going to have the most mass? Your brick, because it is more dense. So inverse means they do the opposite. Direct means they do the same. So density and volume are inverse, density and mass are the same. You should be able to take these two concepts and I'll give you objects and you have to tell me based on different relationships what their volume and mass are. Okay, now we're going to jump into the math part. So one of the key things with the math that we're going to do in here is we're going to do tons of word problems. So you get to write on everything in this class. You need to label everything that's in your problem, put it into the equation, and go from there. Now, with that being said, no work, no credit. So those of you who try to do everything in the calculator, You got to change that a little bit for me because you have to show work to get credit. Okay? Okay, so an object has a volume of 825 centimeters cubed. Now, real quick, side note here. Units of volume. Units of volume will either be centimeters of cubed, milliliters, or liters. So anytime you see that, that means that's going to be your V. Mass will always be in grams, sometimes, but most likely not kilograms. Density will be a combination of the two. So for instance, grams per centimeters cubed or grams per liter. Okay? So you should be able to identify your variables simply by looking at the unit that's after the number. So I know it says volume there, so that's also a key, but that is not always going to be there. So the volume of 825 centimeters cubed is your V. And a density of 13.6 grams per centimeters cubed, so this is our D. Find its mass. So the mass is the unknown. Okay? Now for me, I typically do the equation first and then plug the numbers in. You are more than welcome to plug the numbers in at any point in time that you wish. It all just depends on what you prefer. So I usually change my equation around to find my unknown at first. So the equation is D equals M over V. We are solving for mass. So to get mass by itself, we're dividing by V here, so what do we need to do to both sides? We need to multiply both sides by V. When that happens, we end up with M equals D times V. And now you just simply plug it in. So we take 13.6 times 825. Plug this in the calculator. When you get your final answer, from this point on, your final answer should always be in the correct number of sig figs. If not, you will get a point off. When you plug this in, your final answer should be 11,200 grams. Because I'm showing you here that we only allowed 3 sig figs because remember, multiplying means you look at the least number of sig figs. So 13.6 and 825 have 3. So therefore your final answer can only have 3. Okay, let's try another one. A liquid has a density of 0.87 grams per milliliter. So this is our density. What volume is occupied by 25 grams? Grams is always your mass. And then if you read the question again, you should find your actual question piece. What volume is occupied? So that means we're trying to solve for V. Okay? So we get D equals M over V. Now, if you are algebraically illiterate or struggle with algebra, so forth, this is going to be where you have some problems, is simply by rearranging this equation. We're solving for V. Whatever reason students think at this point that they can multiply both sides by M to solve for V. That does not get V by itself. All that does is does M squared over V. So that is not what you want. A shortcut, when solving for the thing at the bottom, okay, it only works for when you're solving for the variable at the bottom, is to switch it out. So you get V equals M over D. Okay? So now we simply plug it in. 25 divided by 0.87. Now both of our numbers have how many sig figs? 2. So that means your final answer can only have 2 sig figs. So your final answer should be 29 milliliters. Okay, for our last example, you're going to need your reference table out, so please get those out. If you look at the very first page of the reference table, you should see a box at the very bottom that says metal, specific heat, density, and melting point. You're going to be using these densities in just a second for this question. So, what is the mass of 74.3 centimeters cubed of copper? So what do we know in this question? What is the mass? So when it says what is the mass, means that's what we are looking for, of 74.3 centimeters cubed. Remember, centimeters cubed is your V. And that's it. It's the only thing we know mathematically from this actual problem right in front of us. So the next piece, though, is we are looking for M. We are looking for M. We have V, and we also know that it is copper. So with that, knowing that it's copper, you're going to look at the front page of your reference table, and you should see that the density of copper is 8.92 grams centimeters cubed. Again, that's coming from the front page of your reference table. That should be in the back of your composition notebook. So at this point, we now can figure out our equation and solve. So D equals M over V. We're solving for M, so we're going to multiply both sides by V. Those go away, and we get M equals D times V. D 8.92 times 74.3. Now in this one, when you're calculating your final answer, you're allowed to have 3 sig figs. So your final answer should be 663 grams.